Have you ever had to show your ID to somebody to obtain a certain service or to simply be let in? Have you ever had privacy concerns over that? We from Self-Sovereign Identity team of T-Systems Multimedia Solutions will help you to sort it all out. Hi, my name is Ivan and this is my colleague Mujtaba. We are from T-Systems Multimedia Solutions Self-Sovereign Identity team, and today we're going to talk about this technology. Mujtaba, hi, thanks for being here. Could you please explain what is the main motivation behind exploring the self-sovereign identity and what's the problem behind this?
So the main motivation with the topic of self-sovereign identity is that the way we manage our identities in the current world is far from ideal. Let's just take an ID card issued by the government for an example. In such an ID card, we have a lot of attributes, a lot of information that explain our personality. For example, there is my name, first name, last name, date of birth, picture. So there's like a lot of identity attributes that are there. And we use these identity cards to get some service and verify ourselves in different scenarios. For example, if I have to buy liquor from an online liquor store, in some cases in Germany, I have to prove that I'm over 18 years of age. And in order to do that, the requirement is that I should provide some sort of identity to prove that I'm over 18 years of age. So what I do is that I just provide my identity card into this online liquor store and then they save my identity card. In this particular case, I'm revealing much more information than what is required. So it's kind of a privacy pervasive thing because the liquor store does not need to know my name, my first name, last name, my date of birth, my address, for example. They only are concerned about this fact that if I am over 18 years of age or not. And this is a problem, the way we are doing it, because of the nature of how identities are managed. So that is why that is the main motivation of self-sovereign identity, that how we can manage the identities in a better way.
So I presume you are also referring to the so-called all or nothing paradigm, where you have to reveal everything. For example, in the case of a national identity card issued from the government, that you show too much information, which the service provider also doesn't need and sometimes doesn't want to store, also due to the GDPR concerns, the privacy directive.
So it's like bad and bad in both cases. It's bad for the user because the user's privacy is being violated in this case, and the operator needs to manage this information in a better way. They have much more GDPR liability now.
So therefore, we think in our team that the idea of the selective disclosure of the information is a very important thing, and even proving their attribute statements like older than 18. Or is a member of a certain group, etc., is provided by this technology. And therefore, the self-sovereign identity paradigm enables this selective disclosure, and therefore we are actively researching on this.
And also, in order to understand how self-sovereign identity works, I think we must discuss the evolution of user identity as well. So, few years ago in the analog world, user identities was issued by some issuer organization in form of a card. So we usually have an identity card from the government, from our employer, and we store all these identity cards in our physical wallet like this, like I even have right now. So then when we want to use these identity cards to prove ourselves, we would go to any verifier organization. We will simply show our identity card and they will just verify ourselves. In this case, my identity information is not being stored anywhere in the cloud. And there are no analytics that is going on in this particular case. And we could say that in analog fashion, this is privacy preserving. So that's
in a way, yeah.
Yeah, in a way, although not forgery proof, but maybe, yeah. But right now, the way we are managing identity is that we are storing this identity information in cloud servers. And this eventually becomes honeypots for various kind of attacks. And even if we don't talk about attacks for now, there is still pervasive analytics that could be done. For example, racial and behavior profiling of users can be done.
And also, talking of which, the famous Cambridge Analytica case with Facebook data was very profound data breach and
political purposes. So such attacks are possible. So these are profiling of users and behavior manipulation. So these are not hacking, but still breaching the privacy of the users. So, and then we also have had such more attacks. For example, there was an Equifax breach in which credit cards of 148 million users were leaked. And similarly, in Yahoo, the data of 500 million people was also leaked. So, in a nutshell, the way we manage identities and store them in a cloud is not secure. It's far from ideal. And here comes self-sovereign identity. So, in self-sovereign identity, user is in the central piece of the puzzle. So the concept is that the identity information resides with the user in their wallet. And in this case, since it's a digital approach, so it stores in a mobile wallet. So it's just my mobile phone. I can store my identity in my mobile phone. So the way it works is that there is always an issuer organization in a typical identity scenario which issues the credentials to the user. And there is always a verifier entity which verifies these credentials. So the issuer organization will issue the verifiable credentials to the user. User will store them in the mobile phone and then will reveal this identity information to the verifier whenever required, depending on the scenario. And user can control which information is to be revealed and how much it is to be revealed.
Which attributes.
Yeah, which attributes to be revealed. Yeah, for example, in the example of liquor store, now the user can control that, I'm over 18 years of age, and user does not even need to tell them the name, address, or anything. So it becomes much more privacy preserving. So yeah, and in T-Systems, we are basically developing the software components which enable this issuance and verifications of the verifiable credentials in the cloud.
Okay, thanks for discussing these initial points. And it's already clear that this technology opens a new space for a plethora of new use cases, which we are going to discuss with our next guest. Hi, Natalie.
Hi.
Well, could you please tell us how did you get into the Ssi Context?
Yeah, first, thank you for having me here today. During my studies in public administration, I noticed that there's a lot of potential in administrative processes like the communication between citizens and authorities. And while I was searching for a bachelor thesis, I came across a project called Idrees. That's a regional project dealing with SSI and Saxony. And now I'm honored to work with a lot of smart people on that project.
Well, we know there are some countries in Europe which are leading the digitalization. And of course, it will be very interesting to know about Germany, and especially about the Saxony, since we all live here in this case. So could you please elaborate on this a bit more?
Yeah, of course. Governmental authorities are interested in taking part of SSI, especially because of the Onlinezugangsgesetz, which basically says that governmental authorities are required to offer administrative services online by the end of 2022. The problem is that the deadline of the Onlinezugangsgesetz seems unrealistic, and that makes it even harder to imagine that SSI can be implemented in those processes. But it's still cool that communes are taking part in projects like Idrees.
Very interesting. Maybe could you explain us a bit more about the core use cases which are behind of this initiative?
Yeah, first I would say something about Idrees. Mm-hmm. That is a research project and that is promoted by the Ministry of Economy and Climate Change from 2021 to 2024. And the consortium consists of local communes, universities, mobility, IT, and industry companies. And they're all working together on that use cases. And yeah, one example would be, currently we are working on governmental use cases like the residential registration in a city. So when you move to another city, you have to prove at authorities that you are living now on that new address. And going to authorities always means a lot of paper proof and arranging appointments. Yeah, and bad enough is that you have to show your required data in person, such as ID card or certificate of residence. In the future, that won't be necessary to go to authorities in person anymore. So simply you, after digitally sending your required proofs, you will get a credential in your wallet, which proves that you're now living on that new address. And that means no on-site appointments and an automated process, which increases efficiency on both sides. And that's just one use case we are working on. And there are so many more, like getting a ticket for public transport, for example.
Oh yeah. And which cities in Saxony are actually taking part in your experience?
Actively taking part are local communes like Dresden, Mittweida, and Leipzig, I would say, yeah.
Okay, good news for Dresden residents.
Yeah.
And talking about the strategic roadmap of these kind of use cases, could you please elaborate on this one? How does it look like?
Yeah, it's important to emphasize that IDEAL is a research project, so it will end with use cases being tested by pilot users, and thinking far in the future, it will be possible that all persons have access to those use cases. But that's a long way.
And what's your personal attitude to this initiative?
Yeah, I think it's a lot of fun working on that project, and we all have seen that there's so much effort we have to take in that project.
Thank you very much for taking the time to coming here and talking to us.
Yeah, thank you too.
Thanks
Ivan.
a lot. Another exciting use case of SSI are online elections. And this topic we will discuss with our partners from POLYAS.
Hi, I'm Jan Wegner. I'm working as head of product for POLYAS. At POLYAS, we care for democracy. Our goal is to make digital participation a better and easier experience. POLYAS therefore offers an online election platform which has been deployed to thousands of elections and has been used by millions of voters. We're always improving on what we have and leverage new technologies to build on our platform. SSI has the potential to further reduce friction in the voting process. To verify this, we've prototyped a voter registration and identification based on SSI together with T-Systems. One core step of online voting, or voting in general, is to check eligibility of voters and to make sure that votes are only cast once. To do so, voter credentials have to be issued, and in many cases this is done by traditional mail, even in case of online voting. This step not only breaks the digital process, but it also incurs a lot of costs. For our prototype, we focused on two steps: voter registration, so identification based on government IDs, and issuance of voter credentials. And the second step, entering the polling process, so checking eligibility of a voter to enter the virtual polling station. Our prototype was able to prove that the described process of issuing the credentials and checking eligibility could be completely done in a digital way. And that while leveraging governmental ID cards and without collecting personal data within the voting system. Our partner T-Systems was instrumental by providing us with ready-to-use software components. Our developer was able to consume the services quite easily without having to dive deeply into SSI itself. Our development time for the prototype was just a few days, and this allowed us to focus on our core competencies to truly provide a digital process for voters from start to finish. The approach of SSI and the idea of limiting the amount of personal information as much as possible are concepts which fit very well in the environment we're operating in. We're looking forward to what comes next to help making digital participation a better and easier experience.
Now let's talk more about our vision of an SSI as a service paradigm. And for this, we have a guest, Hira, who even won an award for the prototype of this product. Thank you for being here.
Thank you for having me here.
Now let's talk about the main background of this technology and of this vision, please.
So what we are proposing here, or what we are developing in our department, is so-called SSI as a service. So the idea behind is that, well, SSI comes with its own paradigm, and there is a lot of domain and technological expertise that is required to implement SSI as a service infrastructure and integrate it with your business processes. And if you envision yourself as a small, medium enterprise or a startup, maybe you do not have enough resources or energy to focus into an identity management scheme. You would rather want to focus on your customer or on your business processes. So there, the idea is that you can outsource this hassle of identity management and basically take a third-party service for this. Like you buy in the cloud a database service or a vault service, you can also buy an SSI service. And for that, we have created a white label solution that is deployable on multiple cloud infrastructures. For example, we can deploy it on Azure, on AWS, even on OTC, and it also supports multiple blockchains. So that is the vision behind our SSI as a service solution.
On this note, one critical question arises, namely the one of the trust relationship from the end user to the cloud-based solution in this case. Aren't we against the SSI paradigm of decentralization and user control in the cloud-based scenario?
On the first round of it, I agree with you that this doesn't make this sounds counterintuitive, and at first we were talking about the privacy of credentials, and now we are talking about outsourcing all of this issuance and verification process to a third-party cloud provider. We thought about it, and the solution we came up with was that we would run these components inside trusted execution environments. So what exactly is this trusted execution environment, and how would it make the whole process privacy preserving? Think of it like a black box or like a bubble, and your process is running inside this black box. Any data that's going inside this black box and coming out of this black box is encrypted. Moreover, any processing that's happening, all the data that's being stored on memory or on file system, that's also encrypted. So running the system like this gives us the confidentiality of data and code at rest, in transit, and in execution. We also wrote a paper about it, and this solution has been vetted by the scientific community. We even got an award for it, like you mentioned, the Fraunhofer Award. And overall, this solution has been generally accepted by the scientific community.
Okay, great. By the way, we do have a dedicated video on convolutional computing, so check it out. On this note, thank you very much for your insights. And having discussed the idea and the vision of our product, let's delve into the details, technical details behind it with our next speakers. Thanks.
Thank you.
Now let's talk about the architecture with our developers Asad and Tianlei. Thanks for being here, guys.
Thank you.
So could you please explain the technical stack used in the SSI service?
So we develop everything based on open source components offered by the Hyperledger Idrees framework, which is strongly backed by a huge open source community and is compliant with the W3C standards. And the core components of the Hyperledger Idrees framework are Idrees agents. And the core functionality of an Idrees agent is to interact with other Idrees agents and to manage secure storage and to talk to public ledgers on the internet. And furthermore, we can build a controller on top of an agent, which provides the business logic that defines how that particular agent should behave.
And could you please also explain the main components behind the architecture of our SSI ecosystem?
Yeah, so based on that general overview, and we built our own SSI ecosystem architecture. So roughly we can divide it into three parts: the ledger, the agent, and the controller. Yeah, of course, there will be some third-party applications which will trigger our controller to interact with their client agent. So the controller which I mentioned is what we developed in-house, and it consists of three parts: the issuer, the cloud holder, and the verifier. And it will first receive some request from the third-party application, phase it, and then build a new request and send it to the agent. And to the agent, we adopt the open source library called ECAPI, which adheres on the RS RFCs and also can perform some SSI functionalities. And along with this agent, we have wallet DB and we have a tail server. So each agent has its own wallet DB. It is used for store some secrets like credentials, like key pairs, like profiles. And then the tail server is used for the revocation purpose. So for example, when the issuer issues a credential, it needs to contact the tail server.
Okay, and let's be more specific about how credentials get issued and verified, please.
So basically, the first issuer talks to the user in a DITCOM channel about the issuance, and then the issuer issues the credential to the user. The user receives this credential, stored in its own wallet, and this credential can be later used for verification. And the verification starts from the verifier, who will first generate a request. So it's called proof request, and send it to the user. Based on this request, user will generate a cryptographic proof based on, for example, selective attribute disclosure. And then the user will send this proof back to the verifier. The verifier will verify this proof based on the attributes or based on the schema level constraints or something like signature. Yeah, so that's basically how it works.
Okay, you mentioned the DITCOM communication, meaning that the components communicate in a peer-to-peer fashion.
Yeah.
It's not very clear now why do we need blockchain in this case?
Yeah, actually, the blockchain is not necessary if the verifier knows exactly where he can find the issuer. But in the real world, there is a scenario that the verifier normally doesn't know who is the issuer of this credential and where he can find this issuer. And in this case, we need the help of the ledger, which helps us to build a trustless and decentralized system so that the verifier can securely find the issuer.
Okay, of course, talking about this service or this discovery function of the blockchain, we should mention the question which usually arises, well, if you rely on blockchain for this particular matter, then how you can revoke the credential which is not valid anymore if it's stored on the blockchain? Because we know that blockchain is usually immutable for good reasons. So what's your comment on that?
Actually, the credential never goes to the blockchain. It resides with the user wallet, and the revocation has a separate mechanism which involves maintaining a revocation registry in the Tails file that lives on a Tails server, and each time the issuer issues a credential or revokes a credential, this Tails file get updated.
In case of end user credentials, what SSI end user credentials are, what happens if the user loses his phone, for example, and the credentials are gone in this case? So how do we deal with this information availability problem?
So what happens is exactly as in a real life scenario. For example, if a person loses their credit card or bank card, so they immediately call their bank operator or manager and ask them to revoke the old card which is lost and issue a new one. So it happens in a similar fashion. If the user loses their credential, they just ask the issuer to revoke the previous ones and issue a new one.
Okay, thank you for providing some more light on this complex topic. Thank you very much for being here.
Thank you.
Pervasive digitalization is already an integral part of our daily lives. So are the concerns over individual privacy. The future challenges require future-proof solutions, and self-sovereign identity is definitely a part of them.
We really enjoyed creating this video and we hope you learned something new about SSI today.
We believe that everyone should be in control of their own identity.
We envision a world where user identity is managed in a decentralized manner.
At MMS, we're striving hard to turn this vision into reality, and we hope you can join the journey.
Stay tuned and goodbye.